Okay, 5.2, the addition rule and complements. Two events are disjoint if they have no outcomes in common. Another name for disjoint sets, disjoint events or sets, is mutually exclusive events. Okay, we often draw pictures of events using Venn diagrams. Okay, these pictures represent events as circles enclosed in a rectangle. The rectangle represents the sample space, so it's loaded S, and each circle represents an event. For example, suppose we randomly select a chip from a bag where each chip in the bag is labeled 0 through 9. We're going to let E be the event of choosing an even number less than or equal to 2. 0, what? Choose, oh, not an even number. Choose a number less than or equal to 2. 0, 1, or 2. Okay, and let F be the event. Choose a number greater than or equal to 8. So 8 or 9. So that's what's shown here. Notice it's really important that we have the rectangle. A lot of people try to leave the rectangle off, but the rectangle are all of the options that are in our sample space that aren't covered in an event. Okay, so notice that the outcomes in event E are inside circle E, and the outcomes in event F are inside circle F, and all the outcomes in the sample space that are not in E or F are outside the circles but inside the rectangle. Okay, so then we can calculate our probabilities. What's the probability of event E happening? Well, there's 3 items in E, 10 items altogether, so 3 out of 10. What's the probability of event F happening, which was, remember, draw a number 8 or greater, since that's only 2 choices out of 10 possible choices. Okay, so this isn't new. Okay, let's look at this one now. What's the probability that it was an E or F, so that you drew one of these numbers or one of those numbers? Well, now that's 5 options that we could choose, still out of a total of 10 possibilities. So here's where that probability came from. Okay, it's the probability of E, which was 3/10, plus the probability of F, which was 2/10, to get a final probability of 5/10, or 0.5. So this result occurs because of the addition rule for disjoint sets. And actually, here in just a little while, we're going to have another addition rule. And I'm going to basically quit referring to this addition rule because I don't really need 2. I just need one that I can use in any situation. And this one only works for disjoint sets. So be careful about that. Okay, so here it is again, right? The addition rule for disjoint sets. If E and F are disjoint, which also means mutually exclusive, meaning the events cannot happen at the same time, right? So if you're rolling a die, you can't get an even number and an odd number on the same roll of the single die. We call that mutually exclusive. If you're drawing a card, you can't get a king and a queen on the same card. Those events are mutually exclusive. But you can get a club and a king. So clubs, kings, not mutually exclusive. Okay, but if they are mutually exclusive, then here's the probability, right? That's our formula for the probability rule. The addition rule for disjoint events can be extended also to more than 2 events. So no matter how many events you have, E, F, G, you just continue adding them. But they got to be disjoint, right? Okay, so here's an example. So it says the probability model to the right shows the distribution of the number of rooms in housing units in the United States. First, it says verify that this is a probability model. So remember, that means all probabilities have to be between 0 and 1 inclusive, and they are. There's no negatives, and there's none greater than 1. And then if we add them all up, so let me get my pen going here. If we add them all up, it's got to equal 1. So let me grab my calculator and let's do that right quick. 0.01 plus 0.032 plus 0.093 plus 0.176 plus 0.219 plus 0.189 plus 0.122 plus 0.079 plus 0.08, and I got 1. So this is a probability model. So what is the probability a randomly selected housing unit has 2 or 3 rooms? My first question is, are these events mutually exclusive? Okay, can an apartment have 2 rooms and also at the same time have 3 rooms? No. So mutually exclusive. So all I have to do is add. Okay, and look, here's how we do our notation, right? 2 or 3. So I'm going to add the probability that there are 2 rooms, 0.032, plus the probability that there are 3 rooms, 0.093, to get, what is that, 0.125 for the probability that it has 2 or 3 rooms. Okay, what's the probability a randomly selected housing unit has 1 or 2 or 3? Well, what's the probability it has 1 or 2 or 3? It's the probability that it has 1, 0.010, plus the probability it has 2, plus the probability it has 3. All right, I've already added these two, so now all I got to add to that is 0.01, so that gives me a 0.135. Okay? Okay. So what happens when you need to compute the probability of 2 events that are not disjoint? Okay? And they didn't have a nice Venn diagram on these, so we'll just draw one to show, well, if I can get a pen, gotta have a pen to draw, okay, to show what that means. Let's talk about, rolling a single 6-sided die, be our sample space, okay, and we'll say you roll an even number, or we'll let F be, so E is going to be for an even number, and F is going to be for a number less than 4. Okay, so 1 would go in F because it's less than 4. 2 is even. Oh, I wrote greater than. Grief. 2 is even, but it's also less than 4. So it goes right here in this overlapping part of our diagram. 3 is less than 4. Okay, 4 is not less than 4, but it's even. 5 is not less than 4, and it's not even. Okay, and 6 is even, but not less than 4. Okay, so in this case, if I wanted to know what's the probability that it's either even or less than 4, notice what we have, 1, 2, 3, 4, 5. Oh, this would be probability even or less than 4. This is 5 out of 6. Notice if I used my rule from before, if I just added the two probabilities, I would have 3 out of 6 that are less than 4, right? 1, 2, 3. And 3 out of 6 that are even, 2, 4, 6. So I'd get 3 out of 6 plus 3 out of 6. Nope, that's not correct. I can see what it is. Plus, I know it's not a 100% chance. I could get a 5, which is neither one of those. So that's where this, you've got to take away the probability of both events happening at the same time, right? So, because look, this 2 right here, I counted with the F's, and then I counted it again with the evens. So that's okay to do them individually as long as at the end I take away however many, in this case, are both even and less than 4, which that's one number. Now notice I get 6 minus 1. I get the 5, 6 that we could tell had happened. So this is what I was saying. Here's really going to be the rule, basically the only rule I refer to for our addition rule, okay, with an or, because if they're mutually exclusive, then this number down here is just 0. 0, sorry. What's the probability that your number was even and odd? 0. What's the probability your card was a king and a queen? 0. So that's why I was saying we really don't need 2 separate rules. Here's the main one. Okay, the other one's only useful for disjoint sets. Okay, so suppose that a pair of dice are thrown. Let E be the first die is a 2, and F be, grab a pen again, the sum of the dice is less than or equal to 5. Okay, so try to help us out like this. So E, the first die is a 2. That is this whole row right here where the first die is a 2. Also notice when you're rolling a pair of dice, right, instead of just one, a lot of people mistakenly think, oh, there's 12 outcomes, 6 and 6. But no, we really haven't talked about that yet, but that's our multiplication principle. And so it's 36 outcomes, 6 times 6, right? Here's one option you can get, one you can get, one you can get, okay? And the reason these 2 options are different options is think about this. What if one die were red and one were green? This is a 2 on the red one and a 1 on the green one. This is a 1 on the red one and a 2 on the green one. 2 totally different rolls. Okay? All right. And then it says, and let F be the sum of the dice is less than or equal to 5. So let's see where that is. Less than or equal to 5. That's too much. So we've got this right here. Sum of the dice less than or equal to 5. Let's see. All right. So we've got all these options. Okay. So I want to know now the probability of E or F. Okay. So for E, there's 1, 2, 3, 4, 5, 6 options out of 36 possible rolls that you could get. Plus, for F, less than or equal to 5, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 10 out of 36. But because there are some of them that the first number is a 2 and the sum is less than or equal to 5, because it's not mutually exclusive, I counted these in the 2s and then I counted them again in the less than 5. So I've got to take one of those off. So 1, 2, 3 out of 36 needs to be removed. So 16 minus 3, 13 out of 36. Okay, makes sense? Okay, now for the complement of an event. If S is the sample space of a probability experiment and E is the event, the complement of E, now they're doing this unusual notation. They're going to do it like this. It's way more common to see the complement written like this, sometimes even like this. Okay, this is the most common. I will try to use the notation so we can be consistent in what you're going to see in your homework and everything, their notation. But if I slip to this, which is okay, I want you guys to recognize this is also the complement, okay, but I'll try to use this. Okay, then the complement of E is going to be the sample space that are not outcomes. Okay, so another way we can read this, instead of the complement of E, we can just say not E. Okay, so in other words, again with the Venn diagram, okay, here's your event, anything in here. What's not inside the circle is the complement of that event. So that means 1 represents every possibility of that probability experiment, right? Every possible outcome. So if I just take away whatever's in the event, that's going to leave me everything that's not in the event. Okay, so here's another formula. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What is the probability that a randomly selected household does not own a dog? So, pins. So, the probability that you want the complement of people that own a dog, the people that do not own a dog, that's 1 minus the probability that they do own a dog. And let's change this to our decimal. Right? So it's just 1 minus the percent of people that do own a dog. 1 minus 0.316, 0.684. It's as simple as that. Okay, so not. Complement means not. Okay, the data to the right represent the travel time to work for residents of Hartford County, Connecticut. So what is the probability a randomly selected resident has a travel time of 90 minutes or more? Get my pen. Okay, 90 minutes or more. Oh, it's right here. And this is the frequency. So the probability that it's 90 or more, right? More than or equal to 90 is 4,895 over, what do I need? The total possibilities. So let's add those up. 24,358 plus 39,112 plus 62,124 plus 72,854 plus 74,386 plus 30,099 plus 45,043 plus 11,169 plus 8,045 plus 15,650 plus 54,51 plus 48,95. Finally, 382,200. So that's what goes in my denominator. All right, so then 48.95 divided by 382 200. And let's round to 4 decimal places, 0.0128. Now, once again, if you just need to leave your answer in a fractional form, your calculator will simplify this fraction for you. Okay, let me see what I get when I simplify this. 382 200. Oh, it's one of those that's a little too big to simplify. So that was a good thing to see. So if it's very big, your calculator won't simplify. But I know this is reducible because they're both divisible by 5. So let's just do an aside, just for those of you that need this help. I'm going to divide each of these by 5. 48.95 divided by 5 gives me 979. And then 382 200 divided by 5 gives me 76,440. And then let me see if it'll reduce it now that it's a little bit smaller. No, so I'm assuming that's as far reduced as it will go. Okay, so because that, it should simplify that. Okay, now it says compute the probability that a randomly selected resident of Hartford County, Connecticut will have a commute time less than 90 minutes. In other words, that's all of these. I could add all of those up, or I could just say less than 90 is 1, everything 100% minus 979 over 76, 440. And typically when we have large fractions like that, they'll ask us to just round. And when you have smaller fractions like we had in the previous example, they'll ask you to leave the simplified fraction, typically. Okay, so that is 0.9872 rounded. 9872. Okay? So the complement and the addition rule. Let me know if you need any help.